I think we'll just start now. I don't think there's more people joining. Um, so hope everyone's doing all right. And today we'll be covering control flow, conditionals, and iteration. And this is gonna enable us to do something more useful than the programs we could write with the things we learned last time. Okay. So usually in Python, we have the code runs from top to down. But this doesn't have to always be the case. There are ways to change the flow of the code. So in our first example, we have this function that doesn't really do much. We just print, this will print second. And after we define it, we print something and then we call it. So even though we read from top to down, first we just define this function, so it doesn't really do much. Then we call this print first, and then we call this function again. So it's like we're changing the flow of code back to the top. So we go back to here, we print something, and then we continue, but there's nothing really afterwards. So we finish the program. And this is just one way of changing the way our code flows. And there are other ways we can do that. So last time we learned about Booleans, and we didn't really see them in context, but now we can see why they're useful. So say I have this variable called is raining, and we know from last time that this is a Boolean, and I want to, depending on if it's raining or not, print a different message. And if I were to run the code we have right here, I would just get the two sentences printed at the same time. This is not really that useful. We want to change the text we print depending on this condition. And the way we can do that is with if statements. And basically you have if, then you have some condition, and you terminate that with the colons. And if that condition is true, we do something. So we could have more than one line here. We just have. So if I put 3 print statements, we're gonna execute everything that's inside here. If it's raining is true. And then if we want to do something otherwise, so if this condition fails or if it's false, we can use the else keyword. And the code after that will execute if the condition doesn't evaluate to true. So in this case, is raining will either be true or false. And we can also simplify this code slightly. So right now we explicitly compare it to true, but we don't actually need to do that. So we could remove this part because we can. Raining is already a Boolean, so we could already check by default if it's true. So the code we had before was essentially doing true equals true, but because it's a Boolean, the best practice would actually be to just do if it's raining, and this is actual as well. So if you're showing your code to someone, it's much easier to read that than this. It doesn't feel as natural. But this is not the only way. But what exactly is evaluated to true? So the first one we have here is equal to 0, and in Python this evaluates to false. And there are a few other examples. We have a string, an empty string, so there's nothing inside, a number, another number, a sentence, some text inside. Here we have a Boolean, so if we use if we do some comparison and assign it to a variable, we are storing the result of that comparison in that variable. So this will be a Boolean being stored in the variable is raining. And the last one is another comparison. Instead of equals, we have the greater than sign. And before I reveal what each one of these evaluates to, I'm gonna ask you to try and guess which ones evaluate to true, and you're gonna do so equals 0. And if is raining evaluates to true, we print don't forget to bring an umbrella. Otherwise, we just print your. And I want you to pick the values from the list in the item pool that will result in the output being don't forget to bring an umbrella. So you have to decide which ones evaluate to true, such that you get this result printed and not it's not raining at the moment. So I'll release the question and you can just run the code. And you can also so I release the question and you can one answer. This is actually example that's a bit tricky. Ones that you could print with the output being don't forget to bring an umbrella. Also, while we were, if there's anything so far that doesn't make sense, you can either unmute your mic or just type on the Y118 Python channel, and I'll clarify wherever. So number 1 will also evaluate to true, and any number actually above 1 will evaluate to true, and this is mostly because of the fact that if something is none, it will evaluate to false. If there's an actual value there, then we will evaluate to true. We have another sentence inside a string. This will also evaluate to true because it's not empty, right? So Python will evaluate this to true. On the last two, we have two conditions. We have 1 equals 1, which we know is true. So is running is essentially just equal to true. And we print the first print statement. And for the last one, we also have a condition. We know it's true, so 3 greater than 2. And we print the same thing. And the tricky one that we had, there's 2 tricky ones on the question I released. One of them is a string with a space inside. So this evaluates to true because there's something inside. Even though it looks like it's empty, there's actually something there. There's a character. So we evaluate that to true. And lastly, we have a negative number. And this will also evaluate to true because there's something there, right? So it's not empty or anything. So we would print the same statement. There's also more operators and other ways of doing these conditional checks that we haven't seen before. So up until now, we only had 2 conditions. We would either check if is running is true, if it's false, so otherwise in the else. But what if we want to check for more than one condition? And the way you can do that is with this elif keyword. And this is basically the same as else and if, but shortened. And you can have another condition afterwards. So if we were to go through this code, Python will first check if a equals 1, which we know it's false. So if this condition fails, and only if that happens, will Python check the other statements. So as soon as you get an expression here, which evaluates to true, you ignore everything else and you keep going. So, but in this case it's false, so we just move on to the next one. a equals 2, we know it's false, because 3 is different than 2. And finally, we have 3 equals 3, which we know is true. So we print that, and then the execution resumes after the else statement. So if I were to have something here, something, say, test, and if I run this code, we will go through each condition, and then we find a condition which is true, so we print that, and then we just skip to the next piece of code after this whole block. And say you want to check for 2 things at a time, because we know that if something is true here, Python won't bother checking the next condition. And the way we can do that is with these operators and or. And I think it's pretty easy to read the code and understand what it's saying, because the way Python syntax is very close to natural language. So if A and B, this would result in true if both conditions are true. And if you have something that's false, then this fails because you need both of them to be true. And for or, it will evaluate it true as long as only one of them or both of them is true. So A can be true, B can be true, or we can have both of them be true at the same time to get the code inside to be executed. And finally, we have the not keyword, which can be used to negate something. So if we want to check if B is not true, we can use this keyword, and you get the opposite of whatever you have afterwards. So if I have not and then B equals true, if B, we know B is false, so this will be false, but then we have the not, so this whole thing is actually true, and we print that. We print that B is not true. And you could write this in a more concise manner, as we've seen before, which is by removing this equals true. And this is even more readable, so you have if not B, then print this thing, and we can try running the code. So A is true and B is false. So the first one fails because one of them is false. We have if A or B. So one of them is true, so we print that. And finally, we have if not B. So B is false. We negate that, so we get true. And because we got true, we print the code that's inside. 1 second, I think I have a question. Okay. I'll be moving on. So is this clear? Does anyone have any questions about that? If you do maths or anything like that, you might have seen this before. But otherwise, I think it's pretty intuitive to see what the output will be. We're going to move on to iteration. And this is very useful when you need to repeat something, or if you need to go through, for example, here every number from 0 to 10 and do some calculation, or if you want to sum some numbers. And the first iteration thing we'll see are for loops. And the way a for loop works is you will do something for some items you have. And oh, there's someone typing. I don't know if it's a question. Okay, I'll keep going. Someone writes, I'll go back. So in the first example, we have 4x in range, and range is a function. We've seen how to call functions, and it has 2 parameters, 0 and 10. And basically, this is how we go through every number from 0 to 10 and assign it to some variable. So if you wanted to print every number from 0 to 10, you could say for every x in the range 0 to 10, so it's inclusive. It includes the number at the lower bound and at the upper bound. Wait, sorry, it's not inclusive, so the number in the upper bound is not included. So this would actually only print the first 9 numbers in this range. And you could also use this to sum the numbers or something like that. So if I go ahead and run that, so first we print 0. That's the first number in our range. We execute the code inside with x set to 0. Here we just have a print statement, but we might have something else inside, maybe an if statement, or maybe we call some function. And then we go back to the top once we finish this code. So it also needs to be indented like we've seen before. So we know which code is inside and which code is outside. We go back to the top, we increase x again, we get 1, and we keep going until we reach the last number minus 1, because it's not inclusive. And this will go through every integer, so it doesn't include, for example, the 0.1 or something like that. It just goes through every integer from 0 to 9. So here we can see that the problem we've seen before, that it doesn't print the number 10. But we know that if we want to, because it's not inclusive, if we wanted to print 10, we could add 1, so 11. So it will stop once we reach 11 and prints every number from 0 to 10. And another thing we need to know about the range function is that we don't necessarily need to include the lower limit. So by default, it starts at 0 and will go up to, but not inclusive, the number you have as the first parameter in this function. So this would print the same thing as if we had 0, 10. You can check that by running the code, and you get every number from 0 to 9. But we can also use this to, we haven't seen arrays yet, but we have seen strings. So let's say that I want to go through every letter in a string. I can use a for loop for that. So if I say for x in hello, x will be every value inside this string. So in the first iteration, x will be h, so we start from the leftmost letter. And then we do something with that. We just print the h here. And then on the next iteration, we move x again. So now it's e. And we keep doing that until we reach the end. And you can see here, we get every letter on a separate line, because print adds a separate line by default. So we've seen how to use for loops. And now I want you to write some code that, given a number that the user will type, I want you to print every second iteration. And this is just a big word that means print that number to the power of itself, from 1 up to and including the number the user inputted. So if I type 4, I want the second iteration of every number from 1 to 4. And in this case, we would get these 4 numbers here. But we want that to be dynamic, so you can't just call the code that does the iteration for every number manually. And the way you do that is using the for loop. And so you have to think, first, how do I get every number from 1 up to the number the user inputted? And then you do some calculation, and that's it. You'll also need to use input to get the input from the user. This is something we've seen last week. And you also should cast you need to convert this number that the user inputted into an int, into an integer, a number, so that you can use that in the range function. Because if you just call input and try to use that in range, you'd be trying to do something like that. And Python expects a number here. Even though we know it's a number, you need to explicitly cast that to an actual number that Python can understand. So I'll give you a few minutes to write the code for this. And if you finished, just tick the finished box on the item pool. So I have an idea of how many people have finished the exercise. And if you have any questions about the exercise, feel free to unmute your mic and ask. Oh, one last thing. If you want to do a power, we saw this last week. We used this double star operator, where the first number is the base, and the other number is the power. So this is just 2 to the power of 23. So just try to write the code for that. Even if you can just give it a try, and then we'll walk through a way of doing that. But it usually helps if you don't have a lot of programming experience, to think about one thing at a time. So first try to get the number from the user, and then take care of getting every number in the range that we want, and then take care of doing the calculation of the power. And if you do one thing at a time, it's much easier than if you're trying to think through everything at the same time. Also, don't forget you can run your code on the notebook. So if you want to test if something is working, you can just press this button, and the code you wrote will run. You can see if it's working as expected. Does anyone have any questions about the exercise? Because I can see there's only 3 submissions. So if there's anything that doesn't look right, or if there's anything you don't understand, you can ask on the chat or in this channel. I'll just wait a little bit more. Okay, we have another submission. Um, think I'll go through the answer now. So first we want to get the number from the user, and we know we can do that with the input function. So I will have a variable called number. You can call it anything you want. And we use the input function to get something from the user. You don't necessarily need to type something inside, but you can ask the user to type a number or something like that. And we also need this to be an actual number, not just a string. So the way you do that is with this int function, which will convert your string to an actual number that Python can understand. In a real world program, you shouldn't do this usually because the user might try to type something that's not a number. But just for this exercise, we'll go with that to keep things simple. Then we need a for loop with some variables. So we want to go through every number in some range. And I will just call that x. You could call that anything if you want. And we want a number from 1 up to and including the number the user typed. So we know that our range is not inclusive. So we need to add 1 to the number the user typed. So if we add 1, now we know that Python will go to every number from 1 up to and including that number. And finally, we want to print this calculation we're doing. That's the second iteration. So we just need a print statement. And a is already a number, so we don't need to call this int function like we did before. And we want the number to the power of itself. So that's just a, 2 stars, and a. And that's it. It's pretty simple, but it involves a lot of the things we've seen before. So if you try running it and type 10, we get every number from 1 to 10, and then we calculate the power of that number to itself, and we get the output we expected. You can compare with the text above. And the thing I was mentioning that it's not really that important for now, but it's good to know, is that if you call this int function right after input with some string inside, you get an error because you can see here it's not something that Python can convert to a number. So in an actual program, you'd have something that checks if this is a number, and if it's a number, then you convert that to a number, and then you take care of doing the rest of the code. And we have another exercise that involves functions and loops. And as part of this course, we've told you that we want to make the simulation. And we have a map, and we have food that cells can eat. And so we want to make this function called add food that takes 2 arguments. We have num food, so this is how much food you want to add to the map. And we have verbose. So verbose is a Boolean, and it will tell you whether or not we want to print details of what the program is doing. Yeah, and this function will call create food that many number of times. So create food will add 1 piece of food in some coordinates, so you have x and y. But we don't want to put all food in the same coordinates. So we want to generate this random number between 1 and 10 for both x and y. And so if we were to call add food 10 and true, the code would try to call this create food function 10 times. But we also have this true Boolean here in the verbose variable. And so for every food we add to the map, we print this thing here. And this is just so we can see if our program is working as we expected. And the way you can generate random number is there's this function integrated in Python that we haven't seen before. but it's from this module called random. And we haven't covered import statements yet, but it's already there for you, so you don't need to worry about that. And the function that generates a random number in some range is called randint. So it stands for random integer. And the way you can call it is like this. So we have this random, we imported this random module. So this is something that's already included in every installation of Python. And we want to call the randint function from that module. And this takes two arguments. You have a and b. And one is the lower bound, which we know is 1. And the other one is the upper bound. So, and this is inclusive, which can be confusing because we know range is not inclusive on the upper bound. But if you had something like this, you would get a random number in the range from 1 to 20. So we can use one of the iteration for loops we've seen to do something a number of times. So we know that we can, if we want every number from 1 to 10, we can use for I in range 1 to 11. And we know that the code inside will execute 11 times. So we can use that to our advantage to do something an X number of times, which in this case is the number stored in numFood. And propose will be used in the createFood function. So you only need to use that when you call createFood first. So I'll give you, again, a few minutes to work through that. And if there's anything that's not clear, you can ask me or, yeah. I'll go through it again because I'm not sure if this was very clear. So if you call add food, we want to add 10 pieces of food in some imaginary map. And we want those pieces of food to be in random coordinates. And the coordinates need to be in the range from 1 to 20. So you need to generate those numbers every time you call this createFood function. And you need to call this createFood function 10 times because we want to create 10 pieces of food. So once you've finished, if you can please tick finished on the item pool, just so I have a better idea of how many people completed the exercise before I move on. We have 4 submissions. Does anyone have any questions about the exercise? Okay, I'll take that as a no. I'm gonna wait until 6:44, and then we still have another section to get through. So I'll only wait a little bit more before we move on. We have 7 submissions now. So this uses most of the things we've seen before today and last week. So it's a good exercise to see if you're understanding everything we've covered so far. Okay, I'll go through it now. So let's start with the output function, because the other one, we just want to print something for now. We don't have an actual map. And I'll remove this comment. So we have this number, and we want to execute something that many times. So if we use a for loop, and for example, if we had for I in range and num food, we know that range starts at 0 and it's not inclusive. So in this case, range would return the numbers from 0 up to but not including num food. And you might think that maybe that, but actually because we start at 0, we're executing the code that many times, even though the number starts at 0 instead of 1. So that's fine. And then we want to do something that many times. And we know we have a create food function, which we can call. We need the x and y coordinates. And we know we have the random function to generate these random numbers. So we want the x coordinate to be from 1 to 20. And the same thing for y. I'm just going to copy and paste that because I want a different random number. And finally, create food takes another parameter called verbose, which will print this message to let us know that everything is working as expected. But we already have a verbose variable here in outfood, so we can use that. Oops. Oh, I mistyped create food. So we can see that it prints something for every piece of food added, and it tells us the random coordinates we generated. So we can see they're all between 1 and 20. And I think we have 10. I'm just going to... Yeah, we have 10 print statements, so we know that we executed something for the 10 times we wanted. And another thing you could do is we're not actually using this variable I. And if we want to make our code slightly more elegant, we could place an underscore here instead. And this is just a way of ignoring that variable because we're not actually using it. And so it still works, but we're not assigning I to anything because we only care about running some code num food times. So we can just place an underscore there, and it makes our code slightly more it's a very tiny change, but just something you could use. Okay, so we've seen for loops, but there's another type of structure you can use to iterate, and these are called while loops. And what they do is they will keep doing something until some condition is met. So it also takes a Boolean as if you were doing an if statement. But instead of only doing something once, it will keep doing something while that thing is true. So that's useful because, for example, here we're asking the user for some input. And imagine that we want to keep asking the user for input if the first time they entered something is not valid, or in this case, if it's not the correct number. So if we use a for loop, we can only ask a predetermined number of times for input. So we could put a really big number, that would still work. But what if someone went above that number? And that's why while loops can be useful. So the same code we had before, but instead with a while loop would be much simpler. So instead of having for I in range and doing something for a number of times, so here we have a guess and we ask the user for a number. And if the guess is not equal to the random number we generated, so this is like a guessing game, we print correct, and break will stop this loop. So this is something we didn't see above, but if you're doing something and you want to stop before you reach the end, you can use this break word. And what it does is it will stop right there and finish the execution with the code outs afterwards. So if we reach this break statement, Python would skip to the last code after this block of code. Otherwise, we print incorrect, and we check another time. We ask the user for input again, and we do that 10 times. So with a while loop, we can keep doing that while the user doesn't enter the correct number. So here we just have the same code. We generate a random number using the same function we've seen before. We ask the user to guess the number to end this game. And then we have our while loop. So if we break this down, first we have the while keyword. That's what we use to declare this loop. And then we have our condition. So what we want to do is compare the random number with some number the user inputted. So we have the different comparison here. We have the int function because random will be of type int, and input by default will just be a string. So we change that to a number, and we compare if they are equal. So if the user tries to enter a number that's different, this will evaluate it true because the number is different from random num. So we print incorrect again, and we keep going. So we execute this, and then we go back to here, and we try to evaluate this condition again. So we try again and ask the user for a number. So the user might type some other number that's different. If it's different again, we do the same thing, and this will keep going until this condition is met. So if the random number was 10, and finally the user types 10, this will be false. So we stop executing this, and we go to the line of code afterwards, after this block, which in this case just print correct, but you could have something else here. So if you run that, you can try it. I don't know what the random number is, so if I type 2, it's incorrect. I can try again 4. So it will keep asking until we get the right number. So the number was 8. And once we type 8, we compare with the random number. And this evaluates to false because we know 8 is equal to 8. So if you try to do 8 different than 8, you get Boolean false. So we stop executing that, and we go to the next line of code after this block, which is just print correct. Okay. So we have a final exercise on this, and I will give you pretty much the remaining time of the session to work on that. If you have any questions, I can also clarify them. So we want to make a menu that loops indefinitely until the user inputs 0. So 0 will be like our keyword to exit the program. And then for each number that's not 0, we want to do something different. So if the user inputs 1, we want to call this function 1, which prints the number is 1. If the user inputs 2, we call function 2. If the user inputs 3, we call function 3. And if the user enters something that's not one of these 4 numbers, we don't do anything. And as a hint, you can use a while loop. And we also need some if-else statements, so we can compare the number the user typed with the possibilities that we have, which are just 0, 1, 2, and 3. And as a reminder, if you want to exit a while loop or a for loop, you can use the break keyword. So if you had break here, as soon as this code finishes executing and you reach break, it stops doing anything here and skips to the code afterwards. So here break wouldn't be that useful. You'd simply be executing something once and stopping there. But just to illustrate that break stops any kind of loop, whether it's a for loop or while loop, and resumes the code execution with the code that's after this block. Okay, so we've seen if and else statements, we've seen while loops, and I'll give you a few minutes to try and complete this menu. Oh, and once you finish, you can also submit an item pool, so I have an idea of how many people finished the exercise. And again, if you have any questions, you can either send me a private message if you don't want to send publicly, or type on the channel, or just speak here. So we have the three functions. We only need to compare some input and call the appropriate function in each case, or exit the program, which we know how to do. You can also use the code from before as inspiration. So here we're comparing a number, and you can do something similar to that, not quite the same, but yeah. There we have 4 answers, that's pretty good. So if it's 0, we stop the program. If it's 1, we just call function 1. If it's 2, we call function 2, and the same thing for 3. Does anyone have any questions about that? About while loops, for loops, comparing the numbers? Here we get another answer. We have 5 out of 20. No, 6. We still have 3 minutes left, so I'm gonna wait a bit more. Okay, 7. We're almost half. I'm gonna wait another minute and then I'll do the exercise and we'll finish here because we have 2 minutes until 7 p.m. We have 9 answers. I'm gonna go through the exercise now. So we want to repeatedly ask the user for input, and we need to store this input somewhere. So I'm gonna have again a variable called number, and I'm gonna ask the user enter a menu option. And then there are multiple ways of doing this. So I'm gonna do this one way, and you can convert your solution. So if we do while true, this will execute some code indefinitely, but we know that we will eventually break it when the user types 0. So what we could do is compare the input from the user first. So if we want to compare if it's 1, and we don't need to necessarily convert it to a number, because we're not doing any operations or anything like that. We only want to know if it's equal to 1, so we call the appropriate function. So we can call function 1. But there are other numbers we need to check, so you can use the elif keyword and compare number to the other number we want, which is 2. We call function 2. We also need to compare with 3. And we call the respective function. Finally, we also need to check if it's 0. And if it's 0, we want to stop the menu. So we can write break. And we also know from the problem statement that if it's not one of these numbers, we don't want to do anything. So we just ask the user for another option. So if we this is only one way of doing this. So if we oh, and also this one last thing. We need to do this inside because we want to ask the user every time for a new number. And if we run the code we had before, what would happen is if I type 1, it will just keep calling function 1. I'm not going to do that because I think it might crash my browser, but yeah, we want to call this inside so that we get a new number every time. If I type 1, it calls function 1 and we get the right output. You can call with 2, sorry. We get another print statement with number 2. You can call with 3, we get 3. If we type something that's not an option on the menu, I'm going to type a random string. It doesn't do anything, which is the expected behavior. And if we type 0, it just stops. Yeah, so this is one way of doing this. You could also have this other variable that will represent if the program is running. So you could have something like is running, and here we know it's running. And if someone types 0, we could simply type is running equals false. And when we check the condition again, it's going to be false, so we stop executing the program. So sometimes there's multiple approaches. It depends on what you're doing. Some are more elegant, but at the end of the day, they do the same thing. So this is it for our session. Does anyone have any questions about this exercise before we finish? I'm gonna take that as a no.
No questions, but thank you for your session, Thomas.
No worries.
Appreciate it.
I hope
Hopefully
you all
people have
enjoyed
a
it.
bit of a understanding.
Yeah. Yeah, I hope I can see you next week on our next session, which might not be me, but yeah. Thank you for coming.
Thank you.
Thanks, Thomas.